Lakshma Reddy sir. Thermodynamics, some numericals we'll discuss now. A system absorbs 600 joules of energy. That means you are giving 600 joules of energy to a system, and it does work equivalent to 400 joules of energy. You are giving 600 joules. It is doing 400 joules of energy done by the gas. It is supplied to heat. That means I gave you 600 rupees. You spent 400 rupees. So what is your balance now? 200 joules. First law of thermodynamics. The heat given is equals to work done by the gas plus change in internal energy. That is 200. 600 given to you. You did 400 work. So 200 joules is left. Use simple mathematics. During a process of work equivalent to 400 joules is done on a system. Work is done on a system means this much of energy is given to system. Rather than the formula, try to understand the concept. 400 joules you are giving to the system, which gives out of 125 joules energy. This is given out. This you have given to system. System is given out this much of energy. 400 rupees I gave you. You spent you donated 125 rupees. So how much is left with you? Right? 275 joules. Apply very simple concepts. 1 liter atmosphere approximately equals to 101 joules. Okay, na? Simple concept. You convert your liters atmospheres into joules, because 1 atma is equals to how many pascals? 1,01,325 pascals. 1 liter is equal to how many decimeter cubes? 1 atma is equals to 101,325 pascals. 1 liter is equals to 10 to the power of minus 3 meter cube. Now, when you multiply these two, it will become 101.325 Pascal per meter cube. Okay, now Pascal into meter cube, sorry. So Pascal into meter cube is nothing but this is joule. It is SI unit, this is SI unit, so this is SI unit. Approximately you can take 100, no worries. 1 mole of an ideal gas at 300 Kelvin is expanded isothermally, reversibly from an initial volume of 1 liter to 10 liters. Delta E for this process is, okay, 1 mole of an ideal gas at 300 Kelvin is expanded isothermally, reversibly. That means isothermally means no temperature change. When temperature change is not there, delta E change will be 0, because delta E means internal energy change, which depends on kinetic energies. Kinetic energy depends on temperature, and when you are making it isothermally, there is no change in temperature. That's why delta E will become 0. Fine? Don't confuse. An ideal gas occupying a volume of 2 decimeter cube. Right? Sorry. An ideal gas occupying a volume of 2 decimeter cube and a pressure of 5 bar undergoes isothermal and irreversible expansion against external pressure 1 bar. The final volume of the system and the work involved in the process is. See, here again, isothermal. Means temperature is constant, so you can very comfortably apply your Boyle's law. Initial pressure was 5 bar, it became 1 bar. So 5 bar 2 decimeter cube volume, 1 into volume. So volume will become 10 decimeter cube. 10 decimeter cube is present here, here, here. So this is not your option. Then P delta V, pressure into delta V. Pressure is 1 bar final pressure. Delta V means final volume minus initial volume. Final volume 10, initial volume is 2. 10 minus 2 is minus 8 bar decimeter cube. and the conversion is 1 liter atma is equals to 101.325 joules. Just now we have discussed previous question, third question I think. 1 liter bar if you take, that is exactly 100 joules, because 1 bar is equals to 10 to the power of 5 pascals. So minus 8 bar or minus 800 joule. Clear? A system absorbs 10 kilojoules of heat at constant volume and its temperature rises from 27 degrees Celsius to 37 degrees Celsius. The delta E of the reaction is. Delta E is internal energy change. Internal energy change definitely depends on temperature. So now temperature is changed, so internal energy also changes. And if you are giving 10 kilojoules of it at constant volume, okay, a constant volume means work is not done. When work is not done, whatever the energy you are supplying, that is only change in internal energy. Volume is constant means delta V is 0, so work done is 0. When work done is 0, whatever the energy you are supplying, that energy is used for the change in internal energy. Learn concepts. Simple this is. An ideal gas expands in volume from 1 into 10 to the power of minus 3 meter cube to 1 in 10 to the power of minus 2 meter cube against a constant pressure of 1 in 10 to the power of 5 Newton per meter. The work done is, work is equals to minus P delta V. Why minus? Here work is, gas is expanding. Expansion means work is done by the gas. So minus, pressure is 10 to the power of 5 Newton per meter. Delta V is change in volume, 10 to the power of minus 3 to 10 to the power of minus 2. So 10 power minus 2 minus 10 power minus 3. If you simplify this, you will be getting the answer, right? So first you will be getting the answer in regular units of pressure and volume. Convert that by utilizing the regular concept. So it will come 900 joules. P delta V, if you are getting the units as atmoliters, you are using 1 atmoliter is equals to 101.325 joules. 1 bar liter if it is giving 100 joules. And your work done by the gas, so it is minus. 2 moles of an ideal gas is expanded spontaneously into vacuum. Okay, now vacuum, the work done is vacuum, external pressure is going to be 0. When external pressure is 0, P delta V will become 0. So work done is 0. Latent heat of vaporization of a liquid at 500 Kelvin and 1 atm pressure is 10 K calories per mole. Okay, 10 not K, 10 kilocalories per mole. What is the change in enthalpy when 3 mole liquid vaporized at the same temperature? Very simple, he has given latent heat of vaporization of a liquid at 500 Kelvin and 1 atm pressure. Liquid mentioned, 500 Kelvin mentioned, 1 atm pressure mentioned. That means when pressure is constant and the temperature is constant, volume is also constant. When volume is constant, he is calculating delta E. This delta E is given as 10 kilocalories per mole. Now the question is asking for 3 moles, so this will become 30 kilocalories. So 30 kilocalories is the delta E. Now 3 moles of liquid converted to vapor. 3 mole to 3 mole, liquid is converted to gas. So number of moles of gases are 3. This is not considered. So delta N is equals to 3. R is equals to calories, so that is 2. Temperature is equals to 500 Kelvin. So delta nRT will become 3 into 2 into 500. 3000. This is calories or 3 kilocalories. Got it? So delta nRT. Delta N is positive. and already the released energy, this is minus 30 and you are adding plus 3, so this will become minus 27 kilocalories. Sign is not mentioned, so here you can take minus 27. The molar heat capacity of water at constant pressure is 75 per mole, per mole, per mole, per mole. When 1 kilojoule of heat, 1 kilojoule means 1000 joules of heat is supplied to 100 grams of water. This is per mole given. 100 grams of water which is free to expand. The increase in temperature is Q is equals to ms delta T. You can very comfortably use. Here m place you use number of moles. Ns delta T because this S is given per mole. Okay, so you tell me now what is the Q? Q is 1 kilojoule means 1000 joules. M is nothing but number of moles we are take 100 gram of water. 100 gram of water means 100 by 18 to S into delta T. S value is given as 75 joules per Kelvin per mole in place of this. So delta T, if you find out, it will come 2.4. You can check. If you are not getting, I will help you. It will come. Rest questions will do in another. Thank you all.